Hello everyone. So today we are going to explain what are the six quality code tools, their sequence, their now edition that is currently running, and each and every tool separately we will explain in this video. So first of all, we need to understand that what is the definition of quality code tools. So it is a structured set of quality methodologies developed primarily for the automotive industry to ensure defect prevention, risk reduction, and customer satisfaction. So six quality core tools are basically a structured set of quality methodologies that was basically developed for the automotive industry. But nowadays it is being used by other than automotive industry, are also using it for service industry and other service industries and other industries also. The purpose is to defect prevention, risk reduction, and customer satisfaction. Now we need to understand that what are the six quality core tools and their sequence. First tool is basically APQP, that is Advanced Product Quality Planning. Currently, it is running third edition. Now, second tool is basically control plan. Control plan earlier it was there with the APQP. Now it is being differentiated from the APQP, and now it is made a separate core quality tools. That is control plan. This first edition is running. Third tool is PPAP, production product approval process. That is basically fourth edition. MSA, measurement system analysis. That is basically fourth edition. SPC, that is basically statistical process control, second edition. And FMEA, failure modes and effects analysis, that is basically first edition. So this is the sequence of six quality core tools and their edition that I have currently edition that is running at this moment. I have explained. Okay. One important thing that you need to note here that MSA, measurement system analysis, is done before SPC. Why? Because if a measurement system is not correct, then how can I control the process? So to control the process, you should have proper reliable measurement system. That's why MSA comes before SPC. Now we need to understand that who developed these core tools. Okay, who developed these core tools? See, your APQP, control plan, PPAP, MSA, and SPC, that is being developed by AIAG. That is nothing but Automotive Industry Action Group. It's in North America. Okay. And FMEA, it is being done jointly by AIAG and VDA. AIAG means Automotive Industry Action Group, that is in North America, and VDA, Varvandar Automobile Industries, German based. They both have set the standards for the FMEA. Now, we need to understand why core tools matter. Core tools, they basically shift the focus from the defect detection to the defect prevention, reducing the variation, improving the process capability, and ensuring consistent product quality. For all these reasons, we need to have these six quality core tools, and these are so important in the journey of Lean Six Sigma. Hello, this is Surajit Banerjee, a Lean Six Sigma Master Black Belt. I welcome you all to our channel, the Lean Six Sigma World, your go-to place for mastering the concept of Lean Six Sigma in all aspects. Now I will explain each and every core tools separately. Okay, to give a brief idea about these six quality core tools. Okay, first of all, it is the APQP, that is the Advanced Product Quality Planning. Okay, so for the new product development, this APQP is basically used. So for the new product development, as the name implies, that what are the advanced planning that you will do for the new product development so that you can maintain the quality. Okay, so for the new product development to improve the quality, what are the advanced planning that you're going to take? That is comes under in advanced product quality planning. In advanced product quality planning, there are five different phases involved, like plan and define the program, then product design, that is basically design FMEA, process design, process FMEA, product and process validation, and last one is the feedback and corrective actions. So it prevents last stage failures. So that is basically APQP. Now the second one is control plan. The input to the control plan, the input to the FMEA is basically PFD, process flow diagram, and the output of FMEA is basically your control plan. Okay, so control plan, it is a living document that is derived from FMEA that defines process controls, monitoring methods, reaction plans, and responsibilities during production. Now, PPAP is nothing but production part approval process. So PPAP, it basically checks the ability of the supplier so that the supplier is capable enough of meeting the requirements of the customer or not before the supplier start the mass production. Okay, so it checks the ability of the supplier. Now in PPAP, there are 18 to 19 key elements are there. These are basically your design records, okay, engineering change, FMEA, process FMEA, design FMEA, control plan, MSA, SPC study, dimensional results, part submission warrant. All these things are involved in PPAP. Now, MSA is nothing but measurement system analysis. So measurement system analysis, it scrutinizes every component of the measurement system, that from where the variation is coming. It checks whether the variation is coming from the operators, it is from the instruments, it is from the established procedures, or it is because of those environmental factors. So it checks that. Now, SPC. SPC is nothing but statistical process control. So we have to, as the name implies, that we can control the process by the means of statistics. And statistics is nothing but is a way of getting information from the data. So data is taken from a whole population. You take some samples and you basically analyze that, and based on that you basically conclude over the entire population. That is basically done in statistical process control. Now, FMEA. FMEA is nothing but failure modes and effects analysis. So what are the probable modes of failures and what are the adverse effects? That is basically analyzed in FMEA, failure modes and effects analysis. Okay, so it is a risk assessment tool that is used to identify potential failures, analyzes the severity, occurrence, and detection, and prioritize action to reduce the risk. So in FMEA, we find out the one term, that is basically RPN number, that is equal to severity into occurrence into detection, and accordingly basically prioritize the risk, and we basically decide that where we should focus on and where we should take the action immediately. Okay, so that is being done by FMEA. Now, how these quality core tools are connected? APQP is the umbrella, FMEA identifies the risk, control plan manages them, MSA validates the measurement system, SPC, statistical process control, it controls the variation of the process, and PPAP, it validates the ability of the suppliers before you start the mass production. Okay, this is how the all 6 quality core tools are connected. So, if you found this video helpful, make sure to like the video, share this video, and comments below with your thoughts on 6 quality core tools. And let us know in the comments that which tool you have used in your field of work and what you have learned today in this video. Share your experience in the comments. Okay, we have made already separate videos on these 6 quality core tools, so you can go and check into our YouTube channels. We are further going to make in detail about this separately on these 6 quality core tools in coming times. And subscribe to our channel and turn on notification for more insightful content. You can also join our WhatsApp community to get free updates on listener tools and techniques, everything details. Okay, so thank you. I just want to take the opportunity to thank you all from the bottom of my heart for being part of this journey of the Lean System Award. So thank you so much.